Hi all, this is Kishore. Welcome to KASHE channel. In this video, I mainly discuss about the flattening used in both machine learning and deep learning. Flattening is a technique used to convert a multidimensional array into a one-dimensional array. So in this example shown, a two-dimensional array is flattened to get a one-dimensional array. Flattening is useful to reduce the memory usage and training time. And also it prepares the data into the required format for the classification models. In the context of convolutional neural networks, flattening is used to transform the output of the convolutional and pooling layers into the format that can be fed into the fully connected layers for the purpose of classification. Here in the CNN, the bunch of convolutional layers as well as pooling layers are used to extract various features from the image. Here these features are available in the two-dimensional structures. Those structures are flattened into one-dimensional array. That one-dimensional array will be fed to the fully connected layers in order to get the classification label. Now we'll look at various ways of getting this flattening by considering the simple examples. First we will see how to flatten a two-dimensional list. For that I am creating a two-dimensional list. So a list is having two elements in it, in which each element is another list. You can consider this list as 2 by 3 matrix. Then I am converting the two-dimensional list into a one-dimensional list by using a for loop. Here I am taking the empty list first, and then I am accessing each row from the two-dimensional list. From each row I am accessing the individual element, and then I am appending that element into the one-dimensional list that I have created. Then I am displaying the one-dimensional list. Then I got a one-dimensional list with all the elements present in the two-dimensional list. So in that way, by using two for loops, we can convert a two-dimensional list into a one-dimensional list. So next we will see how you can flatten a two-dimensional numpy array. In this case it is very easy because the numpy array object is supporting a method called as flatten. By using that flatten method, we can convert your multi-dimensional numpy array into a one-dimensional numpy array. See, here I am importing the numpy with an alias np, and then I am creating a two-dimensional array. Now the shape of this particular two-dimensional array, array2d, is 3, 2. And then I am using the flatten method associated with the numpy array object in order to convert the two-dimensional array into one-dimensional array. Then I got a one-dimensional array with all the elements present in that two-dimensional array. And then I am going to use a Keras library, which is a deep learning library we all know. In that case, how you can perform this flattening? So first of all, I am going to import the sequential API in order to build the model, and then a flatten layer. Here I am going to implement a sequential model object by adding the flatten layer with the help of the input size. And then I am going to use the predict method associated with that model object in order to provide the flattening for the two-dimensional array that previously we have. Now I am displaying the one-dimensional array I got because of this flattening layer. Then I got all the elements present in the two-dimensional array into the one-dimensional array. In the same way, you can use the same method in order to convert a three-dimensional array into one-dimensional array. Here I have created array 3D, which is a three-dimensional array. Now I am displaying that array as well as its shape. See here, this is a 2, 2, 3, which is the shape of this three-dimensional array. And then again I am creating a model by using the sequential API, where I am adding flatten layer with the input shape of three-dimensional array. And then I am again using the predict method with model 2 to convert this three-dimensional array into one-dimensional array. If I display the one-dimensional array, I got all the elements present in the three-dimensional array flattened into this one-dimensional array. So that's all guys. Bye.